Welcome to the deep dive. If you're fascinated by how elite athletes fine-tune their training, really squeezing every last drop of benefit out, well, you're in the right place. Today we're getting into the weeds on performance optimization, specifically high-intensity interval training, or HIIT.
Yeah, it's a cornerstone, but there's always tweaking, always looking for an edge.
And we've got some fresh research to unpack. It's focused on academy-level rugby union players. The paper's called Fast Start Strategy and High-Intensity Interval Training in Rugby Union Academy Players. Authors are Louit, Virgile Merlen, Jonathan Ward, and Olivier Gavarry. And you find it in the Journal of Sports Science and Medicine, 2025, Volume 24.
Right, and our mission really is to see what this study tells us. They compared a standard HIIT approach, constant effort, with this new fast start strategy, HIIT-FS. The big question for you listening is, can you get a bigger physiological hit, more adaptation stimulus, just by changing how you structure the intensity, without actually making the players run further or harder overall?
Okay, let's set the scene first. Rugby union. Why is aerobic capacity, this VJO peak thing, so critical?
Oh, it's huge. Think about the game. It's not continuous running, it's bursts, sprints, tackles, getting up, doing it again for 80 minutes. Your ability to recover between those high-intensity efforts, especially late in the game, that often decides matches. And that recovery ability, that's driven by your aerobic engine.
So VJO peak is like the size of that engine.
Exactly. It's your peak oxygen uptake, how much oxygen your body can use per minute. A bigger engine means faster recovery, more repeated sprints, better tackle success, just more work rate.
And HIIT is the standard tool to build that engine efficiently.
Yeah, it's time efficient, very effective. But the real driver of adaptation, the thing that makes your heart and muscles change, is the total time you spend working at a very high percentage of that VO peak. We call it T, 90% VO's peak.
Yeah.
Think of it as time spent in the red zone. The more time you accumulate there, the stronger the signal for your body to adapt.
Okay, so if we want more red zone time without just running longer, we need a smarter approach. That's where this fast start idea comes in.
Precisely. It's been looked at in running, cycling, pure endurance stuff. The idea is you hit it hard right at the start to get your oxygen uptake system firing on all cylinders really quickly.
Which gets you into that 90% zone faster.
Right. But this study is pretty novel because it's applying it to rugby players. Team sport context, very different demands than steady state cycling. They wanted to see if that fast spike approach works here too.
All right, let's dig into the actual study design, the nitty-gritty. They had 8 male academy rugby players. First step, figure out everyone's individual fitness level using the 30-15 intermittent fitness test, the 30-15 IFT.
That gives you VIFT, maximal intermittent running velocity. It's crucial because it personalizes the training intensity. We're not just picking arbitrary speeds.
It's tailored, so everyone's working relative to their own maximum capacity.
Exactly. Ensures the stimulus is comparable, physiologically speaking.
Okay, then came the 2 main sessions, done in random order. First, the classic approach. HIIT-C for constant. This is 2 sets of 8 repetitions. Each rep, 30 seconds of running, 15 seconds of rest. The key is the running was at a constant 88% of their VIFT.
Right. Steady, hard work. Pretty standard HIIT protocol.
Then the challenger, HIIT-FFSS for fast start. Same structure, 2 sets, 8 reps, 30 seconds on, 15 off. But here's the twist. The first 4 reps of each set were way faster, at 98% VIFT. Nearly max effort.
A real kickstart.
Then, for the last 4 reps of the set, they dropped the intensity right down to 78% VIFT.
Now, here's the really clever bit, and it's vital for understanding the results. They designed it so the average intensity across the whole set, those 8 reps, was identical in both protocols.
So even with the 98% sprints in HIFS, when averaged with the 78% efforts,
it came out to exactly 88% VIFT, same as the constant HITC session.
Wow, okay. So the total workload, the average demand was matched. They weren't comparing a harder session overall to an easier one.
Correct. They isolated the effect of intensity variation within the set. Does starting fast and finishing slower give you a different result than just staying steady, even if the average effort is the same?
And that role, what was the main finding?
It absolutely did. The fast start strategy, HIIT-FS, significantly boosted that key metric we talked about, the time spent in the red zone. T, 90% VSHO pick.
Okay, give us the numbers. How big a difference are we talking?
It's pretty striking. Over the whole session, HIIT-FS racked up 318.8 seconds at or above 90% VSHO peak.
Okay, and the standard HIITC?
That was 230.6 seconds.
Whoa, that's What, over a minute and a half more time in that crucial adaptation zone?
Yep, an increase of 38.2%, with a large effect size statistically speaking, almost 40% more stimulus time.
For essentially the same amount of running time and the same average intensity. That's huge. That's getting way more bang for your buck.
It really is, and when you look closer, you see why. The advantage was massively front-loaded. Set 1 of the fast start protocol showed a 40% jump in that red zone time compared to set 1 of the constant protocol.
So it's all about that initial burst, those first 4 reps at 98% VIFT.
Exactly. It's about VSHO kinetics. Basically, how quickly your oxygen uptake responds. Hitting that near maximal speed right away forces your VSHOs to ramp up incredibly fast. Think of it like flooring the accelerator in your car. You get up to speed much quicker than if you gradually increase pressure on the pedal.
So even though they slowed down later in the set, their oxygen uptake was already so high from the start
that it stayed high, accumulating more time above that 90% threshold. The system got a shock start and remained elevated.
And the other physiological data backed this up.
It did. They saw significantly higher average ventilation, how much air they were breathing, about 6% higher in the fast start group, and also higher average respiratory frequency, how fast they were breathing up by about 5%. It shows greater overall metabolic and ventilatory stress driven by that fast start.
Interesting. What about heart rate? Did that show the same big difference?
No, actually, and that's also quite telling. Measures like average heart rate or time spent near peak heart rate showed no significant differences between the two protocols over the whole session.
Why not, if the oxygen demand was so much higher initially?
It fits with what we know about physiology. Heart rate response lags behind oxygen uptake. VSHOs can spike very quickly in response to intense effort, especially short bursts like these 30-second intervals. But your heart rate takes a bit longer to catch up and reflect that overall strain across the entire set. It confirms that VSHO is the more sensitive marker of that internal workload here.
Okay, so internally, physiologically, fast start wins big time. More adaptation stimulus. Now, what about the external load, the actual running? This is where it gets really interesting for coaches, right? Because the goal was more internal stress without more external stress.
Precisely. And they tracked this using GPS, measuring total distance, how far they ran above certain speed thresholds.
And the result?
This is the kicker. Despite those really fast 98% VIFT intervals at the beginning of the fast start sets, there were no significant differences in any external load measure.
Seriously. Total distance covered was the same. High-speed running distance was the same.
Statistically identical between HIIT-FS and HIIT-C.
Wow. Okay, so you're getting almost 40% more physiological stimulus, that red zone time?
For the exact same amount of running, same distance covered.
That sounds like the holy grail for conditioning coaches, especially in sports like rugby, where you're constantly managing overall running volume to prevent injuries.
It really does. It suggests you can enhance fitness gains within a packed schedule without piling on extra running mileage, which carries risks. It's about training smarter, getting more from the same external input.
There's always a but, isn't there?
There is, and it's a big one. It's about how the athletes felt. Perceived exertion, RPE.
What did they expect versus what did they find?
Well, the hypothesis was because the average intensity was matched, that 88% VIFT average, the RPE should probably be similar between the two protocols.
Makes sense. Same average effort should feel roughly the same, maybe.
You'd think so. But nope, RPE was significantly higher for the fast start session.
How much higher are we talking?
On the Borg CR10 scale, where 10 is maximal effort, the constant HITC averaged an RPE of 7.8. Pretty hard, as expected. But the fast start HITFS, that averaged 9.0.
9 out of 10. That's approaching maximal perceived effort. That's a 15% jump in how hard they felt they were working.
Exactly. A very noticeable difference in subjective feeling.
Okay, that's the potential wrench in the works for practical application. You tell your players, great news, this session gives you 38% more fitness benefit. And they say, yeah, but it feels 15% worse.
Yeah, that's the trade-off. Why does it feel so much harder? The researchers suggest it's likely down to that initial shock, starting at 98% VIFT. Even though the intensity drops later, that initial very high intensity imposes a greater immediate biomechanical stress, a higher instantaneous oxygen demand right from the gun.
So that feeling of intense strain early on colors the perception of the entire session, even the easier bits later.
It seems likely. That initial physiological and mechanical jolt just lingers in the perception of effort.
So summarizing the practical implications then, HIIT-FS, great for maximizing internal physiological stress.
Without adding extra running distance or external load. big tick for efficiency and injury management potential.
But it comes at the cost of feeling significantly harder.
Right, which affects how and when you'd use it. The study suggests because the benefit is so front-loaded into those first few intervals, it's probably most effective when you only have time for a limited number of sets, maybe just one or two.
Like if you're squeezed for time before a game week or fitting conditioning into a busy schedule.
Exactly. Get in, get that massive stimulus quickly with one or two HIIT-FS sets, and you're done. Plus, the high speeds involved make it very specific to the demands of rugby, those accelerations and sprints.
But coaches need to be mindful of that RPE.
Absolutely critical. You can't just hammer athletes with sessions that feel like a 9-10 effort all the time. Burnout, poor adherence, potential for overreaching. So this needs to be balanced. Maybe you use HITFS strategically when athletes are fresh, maybe during preseason blocks for a powerful stimulus. But you'd mix it with standard, less perceptually demanding HITC sessions to manage overall fatigue and tolerance.
It's another tool in the toolbox, but one that needs careful handling.
Precisely. It's not a replacement, but a potentially powerful addition for specific circumstances.
So the big takeaway for you listening, just changing the structure of your intervals, even when the average intensity and total work are identical, can dramatically change the physiological outcome. Nearly 40% more adaptation signal in this case.
Which really opens up questions about optimizing all kinds of training. But it's important to remember, this study looked at the acute, immediate effects. What we really need now is longer-term research. What happens if players use this fast start strategy consistently for weeks or months? Do those acute VJO benefits translate into better game fitness, better repeat sprintability over a whole season? That's the next step.
That's definitely some food for thought, thinking about not just what you do in training, but how you structure it. If you want to really get into the weeds on the kinetics, the heart rate data, all the stats, we absolutely recommend reading the full article by Louit and colleagues.
Yeah, the details are fascinating, especially if you're a coach, an athlete yourself, or just someone really keen on maximizing workout efficiency. Understanding these nuances is key.
And if you enjoyed this deep dive into the science of sports performance, make sure you follow the channel and switch on notifications. We'll be back soon with another analysis.
Definitely. Lots more research out there to unpack.
Okay, let's leave it there for today. Keep thinking critically about